Dobrý deň, vítam vás. Mali sme trochu technickú prestávku. I see also our Erasmus students here. So I wanted to ask you, would it be a problem for you, for the rest of you, to have this lecture in English? Yes? Why? Dostupné sú náhrávky v slovenčine, keby niekto sa cítil, ako že by potreboval počuť minuloročné, predminuloročné. Ako samozrejme, že budem hovoriť niečo iné teraz, ale nie úplne iné. Takže možno trochu iným spôsobom, ale v zásade. Máte nejaký kategorický problém? No. That's perfect. So this lecture will be in English then, and I hope that all subsequent lectures will be in English as well. As I mentioned, you have the recordings of last year's lectures and a year before that in Slovak, so I guess that won't be a problem. Before we start with the actual lecture, I think that we might give a moment to projects and what do we expect from you in projects. I received 1 or 2 emails asking me to clarify some things. Maybe it's better to do this here. I will be explaining. I explained this already to our Erasmus colleagues. But I think it's kind of this is an opportunity to discuss this further. So I don't want to speak too long. I would say a few things and then ask you if you have any questions to this, because you will be hearing this again. You heard some version of this in the labs, and now we have this opportunity to discuss this and clarify this like here all together. And even Jakub is here. Maybe Victor will come or is here somewhere around. So we are like not all of you, but some. We are here, so let me just emphasize that projects are here in this course. Always they are a learning opportunity. So we want you to work towards some goal in order to learn some further things. Seemingly, everyone will then learn something different, and somebody could ask, then what kind of course is this when there are no strict rules? But there are so many different views on architecture, and I guess on other things as well, that this kind of learning is actually beneficial. And you will actually touch many of the common things, and the most important common things that will occur throughout this course anyway. But your paths will be different. And this is only natural. So everyone has their own path of learning. And the project is exploratory. I heard that Victor frightened you a bit that some research is expected from you, and this sound maybe too complicated, but it actually isn't. All we want is that you to take in consideration some of the existing approaches, try to maybe apply them or modify them or combine them. So we will see based on what you choose to do, what it takes, or what's the best option, and what are you going to try. Maybe this will not be 100% clear in your project objective, but during the first weeks of working on project, you will find your way. or you should find your way. There are consultations, so you'll talk to each other and talk to your teacher, and maybe some of you will already present some initial things regarding your projects, so this shouldn't be a problem. So maybe it's better to say that we expect some methodological contribution. This does not mean that you need to come with a completely new method or so, but even if you apply something already, what is already being used and applied in practice, the examples that you are going to use give you some context, give you some kind of a situation that is necessarily at least a bit different than the one that the original authors or the authors of the original approach assumed. So you will need to clarify some things in the approach, to set things right and so on, and necessarily or inevitably you will come to some kind of unclear points, and you will try to make them work one or the other way and so on, and that is your contribution. Out of that, you will write your report. It will be supported by the artifacts you played with. Might be code, might be models, might be some schemes of people, organization, pattern definitions, or whatever. Further things that you might have. So this is not limited. So that's it. So now back to you. Do you have any questions to this? You can ask them in Slovak as well. So it seems that you who are here have no questions. So I hope this clarification will be of some value to those who are not here, who will be listening this recording. So now, back to the lecture. I did not explain this last time, but I decided to change a bit the order of lectures, or I'll be changing the order of lectures. Maybe not too much apart from this change. If you look at the list of lectures, you would see that today's lectures should be devoted to using UML to capture software architecture. I guess we will touch these things as well in this lecture a bit. But I think that you don't need too much of UML to understand what is the content of this lecture, and I will explain all the things that will occur that would look like UML. So I think we can go directly into something that is essential for understanding architecture, and we will make some comparisons to building architecture. Actually, let's start with a kind of a introductory and inspiring question to you. We will not spend too much time on this, but think for a moment. When you think of architecture, because we would like to have a good architecture, yes? We don't want some crappy architecture that doesn't work, that I don't know what, or I don't want to talk too much about this at this moment, because I want to hear from you some things, some opinions on what What do you think a good architecture should look like, or what makes a good architecture? By architecture, I think mainly software architecture, but you can make parallels to building architecture, and in fact, I will be making them as well across this lecture. So let's use this method of like conversational thinking. So talk to your neighbor, like as you're sitting close to, maybe if there are three of you sitting next to each other, then if somebody is alone, so you might like to move to talk to somebody, and give me some hints. So first talk to each other for a minute or two, and then I will then share your opinion with us. So what would you say? You can use Slovak as well, no problem. Nastaviť pravidlá a dodržiavať ich. So set rules. And here to them. One opinion, some other opinion. What makes a good architecture, or how to get to a good architecture? Originally I thought this question as how do we know that the architecture is good? Je zrozumiteľná, so understandable, comprehensible. Comprehensible. It's a kind of sounds more sophisticated when you say comprehensible than understandable. Shouldn't be overly complicated. Maybe not overly complicated would be better or shorter. No. What should I do now? Overly complicated. Anything else? Any other opinion? So too complicated architecture is not good architecture. When you look at some software architecture, or how do you look at this architecture at all? How do you get to know the architecture? Well documented. Anything else? Proširiteľná. Niečo som stlačil. Press something. Oh. So it's. I will use maybe the keyboard next time. This is not very much for me. What did I do? When I do. Can I type? No. So extensible or extendable, who knows what's the correct word for what purpose? So that you can extend the architecture. So that's the point. I think I will. Oh, I can write now. So extendable. Which one? What is correct? So it can be extended. So you have some version of your architecture, some of your software system, and you are capable of extending it. Any other opinion? Yes? Design should be understandable. I think we have this one here, comprehensible. Comprehensible. Do you mean the same? Yeah, like it's not. We did not say that the design is comprehensible. Okay, but we can remember this. Okay, so the design should be comprehensible, understandable. You should be able to understand what is it about. Anything else? So actually, we started by having some that it's good to have some rules and to adhere to them. I would say that I don't know. Maybe you will correct me, but this is interconnected with comprehensibility. Somehow, when you have a set of rules, then if you know how your architecture, by what rules it is being built, then you will be able to understand it. Otherwise, if you are not capable of understanding software architecture, you are going to be lost. You will not feel well. So you are like an inhabitant, like as a developer or a designer or a software architect or whoever, like a stakeholder of a software system. You are inhabiting that software architecture. And as an inhabitant, you want to feel good there. You don't want to have trouble of, like when I would like to use this architecture, if it would be too complicated for me to sit or use these spaces or use this system as it is complicated like this, I do not feel well. I'm not comfortable with this architecture if the lights are not good and so on. So the same with software. And also, this third thing shouldn't be overly complicated, is also related to comprehensibility, I would say. Feel free to jump in if you think otherwise, with some notes, remarks, whatever. You don't even have to raise your hand. I won't be angry. Shouldn't be overly complicated, yes, and well documented. Again, why well documented? This sheds a bit of light on that the main artifact that we rely on, like for the software to work, is code, and it might be kind of obscure. It might not be clear or immediately clear from that artifact how the software system is organized. So we won't be able then to extend it if we don't understand it. So it's very important for us to know, and if we have these rules, if we know by what rules and maybe it's not the problem just or the thing is not just in knowing the exact rules, but what kind of rules, what can we expect, and how to express the whole software system in a kind of a uniform way. You can see this tendency in many programming languages. Probably all programming languages started like this, like setting or relying or choosing one particular notion out of which the whole world should be built. Like functions in functional programming, like classes in object-oriented programming should be objects probably there. And if you know about Smalltalk, so this tendency was kind of in some languages was more strict, and there you actually perceive even if expressions as objects, and everything is based on sending messages between objects. However, the real world is much more complicated. And this is kind of a very clean and like simple world with kind of these limitations. The real world encompasses many more different structures and breaks this kind of symmetrical way of thinking, like that all the things are equal and can communicate equally and so on. So then those kind of real world, more real, like Smalltalk. I wouldn't say that Smalltalk wasn't a good attempt or is not a good language, but those languages that are mostly used, well, maybe it's not like this, it was like this in the past, but even these newer languages, C++, when you take C++, it's a multi-paradigm language, so it encompasses many different ways of expressing things, and sometimes it's a real mess, but we need this because the reality is complex. So anyway, we would like to we feel better if we know out of which things are composed. What I don't see here, whose perspective I don't see here, is user's perspective. Because we are building software systems for end users who will be inhabiting practically these systems. So maybe enough for these introductory thinking of the subject, let's move further. Maybe somebody would. I was expecting somebody to say that there are actually no good software architectures. It's all a mess. Maybe somebody would ask or point out that really software architecture like extendable comes close to that, but that software architecture should be reusable. So we should maybe these rules come close to this as well. And when we come to reuse and understanding and everything, and what those rules could be, I would offer another notion, which is a practices. What practices do we use to come to some solution? There are, of course, kind of certain methods, and when you follow a certain method, you might come to some to an expected result. But usually, strict methods for things alive and complex, like software architectures, are too limiting. So, what could be those practices that actually are proven and we know they work and that we can rely on would be in software architecture? So, this good software architecture should be, as I mentioned, good also for end users or users, and should be good for us developers, and in a way for all stakeholders. So even maybe those like who are like managers or some other stakeholders who are not directly involved in software development are coming in touch with software artifacts as well. And as we are getting closer to what those practices that we should be kind of might be using to express our software architecture are, and actually the title of this lecture reveals this. Let's imagine one more thing before approaching this. Imagine you're building a house. So we are searching now what are those building elements that we would use to express our architecture. Imagine that you're building a house. How would you design it? What would you use? What kind of? I don't want to to name the notion exactly, but can you describe me a bit? How would you approach designing a house? So imagine you have an opportunity to build a house for your family, for you, and how would you express this? Give it a minute. I would try to resolve the issues, if these writing issues. Maybe we don't have to write anything actually, but let's be prepared for this. So talk to each other, please. What would be your approach to building a house? How would you tell anyone, to the people that have to build your house, how that house should look like? So how would you do that? What would you tell them? For example, it can be an example. Build me a house as big as the Empire State. Beat the sheikh in Dubai. What would you tell them? Any hint? Any desire? Nothing? So you're satisfied with what you have now, don't want to change it. What I think I would do, I would come out of my needs. So I would think, what do I need? Do I have a small family, for example, or is it just a fancy house for me? Somebody would say, okay, I would like really the biggest house in the neighborhood, at least, if not in the world, or the most fancy house, I don't know, the strange house that looks like, I don't know, like this, a strange house, reversed pyramid or something like this, with fancy windows like this. It looks really strange. So there are such houses. And in a way, all modern buildings are kind of a challenge for the architects to show very different ways of expressing themselves and so on. But the question is, how do the inhabitants feel inside of these structures? And we have actually, there is a building like this, similar, but I think it's like a rather square base. So it's better now. In Bratislava, this is I think the Slovak radio was situated there. Reverse pyramid like this, and I've never been there, but I heard that people feel really depressed, especially those that are like inside. If you imagine, if you are on site, at least you have some light, but inside you don't have any windows, anything. So, and there are huge spaces like this. So it looks like an interesting object, but it does not. I don't even feel well near that building. So even the outside impression is not good with such architectural experiments. So this really good architecture comes out of the needs of the inhabitants. So with a house for a small family, you would imagine or think, okay, as a family, what spaces do I need? How this house should be organized, or what actually forces are creating a pressure on me to decide for something. In a small family, there are adults, there are children. So sometimes you want to be with your children, sometimes you don't. And the same for you. It's also with children too. So sometimes your children want to be with you, and sometimes they don't. Eventually, you need some shared spaces and some individual spaces for adults, for children. Presumably, each child might like to have a room, but maybe you don't have enough money for this. So that's another thing that we did not mention. in our like initial analysis what a good architecture should be. So the good architecture is certainly one that you can afford. If you cannot afford it, then what's the use of it? So this small house, like if we draw a scheme of this small house, so there should be like a space for children, space for adults, and some kind of a shared space. This is not really a house. It's a kind of an organic structure, like when a new being is conceived and then it's not yet a human being. It starts out of some cells, and then the structure is starting to emerge. So in this way, this architecture is can be perceived, and probably it is so. It is a live thing. If you understand it like this, so you actually react to the forces that make you decide so, to arrange your house so that there will be some shared space where there could be like some toys mixed with your things, and nobody will care about this. But then you will have your, like, maybe there will be several rooms here, maybe a bedroom and a living room, or even more rooms if you can afford this, or if you want them. But certainly you would need some rooms where it's really your realm. So we are actually generating structures based on the conflicts of contradicting forces. On one hand, you want to be with your children. On the other hand, you want to have some individual spaces for you, and the same holds for your children too. So with this, let's look at another example. If you in building architecture, if you want to spend the time with your family or with people, but at the same time you want to have some individual activities, or to have some private conversation with somebody, how can you do that? If you have a room like this, there's a table, and everyone is around that table, so you can't escape. But you don't want to be completely separated. So this is the conflict of the forces. So one solution that comes and is very much applied in architecture are alcoves, and there can be several, maybe some symmetrical like this. So you can have a place for sitting for the two, and kind of a central table or some central facilities for like gathering with all the people together. But when you sit aside like this, you also hear what do they like now. So you're having your private conversations, but at the same time you're observing a bit of this central activity. And alcoves, these are called alcoves. Možno výklenky, alebo také niečo, keby sme po slovensky, neviem, či je nejaký lepší výraz. So alcoves, people need to sit together, but they also need privacy. Roughly. This is a conflict of contradicting forces. These alcoves might be a part of a house for a small family that I mentioned. But they might be also useful in other architectures as well. And a house for a small family can be a part of a house cluster, like a neighborhood. And maybe we can imagine further units of modularizing this building space, all the way to some independent regions. Independent regions like parts of a state. This is a kind of like it might be perceived as a political issue, but also this is an organizational issue. Many states are organized into like independent regions because the people who inhabit these regions need to take care of these regions. Otherwise, things won't work. If we get back to alcoves, it might be really good, and we feel good. Observe this. I have an office, and our Erasmus colleagues visited me there, and they were amazed how nice the office is. I'm not very satisfied with it. It is spacious. There is a nice sitting space there, but it doesn't feel right somehow. And I know why it is so. And I'm thinking what to do to move it to the window. So if you have a window like this here, and a sitting place here, so you are composing two patterns, because we as human beings, we like to be seated comfortably, but we also like light. So if we have a sitting place too far from the light, from the windows, we feel this as awkward, strange, not completely right. And these are actually things that can be composed, as we see here in this drawing. And these two things are actually patterns, not of software systems, but of building architecture. And a house for a small family is a kind of a, like this is some structure above alcoves, because it contains alcoves. And a house cluster also contains houses. Each one of these patterns can be expressed as a conflict of contradicting forces, though, but also we can then elaborate each of these patterns in details. And even alcoves and whatever occurs there, like even the table, the chairs, and especially the doors to the rooms, and the ornaments on these doors are also important. And in our software world, these are like really tiny details of code. And you may really, like you felt this as programmers as well, like you're not satisfied with how things are expressed in code, and you're modifying tiny details. And the functionality remains the same, so you're doing some kind of refactoring just to get this in to some form that you're satisfied with, that because you live in that code. And it is kind of a unnatural. No, we cannot stand these things if they are like seem to be kind of artificial or not sufficiently alive. So this is a vertical decomposition, and this is a kind of horizontal peer-to-peer, to say so, composition of patterns. And this is the work by Christopher Alexander, who is a building architecture more famous in our world than in his own world. Unfortunately, he passed away this year, but he left really capital work on patterns, and we observed patterns from him, and his collaborators, and the idea entered our world first as some would say the gang of 4 patterns, those famous 23 patterns: observer, visitor, and like. But there were some works before that, most notably a book by Jim Coplin on idioms of C++, of the C++ programming language, which are actually patterns as well. And many other patterns have been discovered ever since then, and documented in many papers and books. And some of these structures probably are not really patterns in that Alexandrian sense, as we could say, but are some solutions to some problems. So not any solution, just any solution to any problem is a pattern. Patterns have to have this property of being composable with each other, and with building and improving the thing that you build, the whole, piece by piece. And if you recall how important and how it's actually it is essential for modern software development is iterative software development. So piece by piece, iteration by iteration, you build gradually your system. Okay, if you have a clear specification, then it's fine, but this is a living thing. So it's the same with the building architecture. It should be adaptable in some sense, extendable, and to provide better environment for its inhabitants. So we form these pattern sequences as kind of solutions to more complex problems. So we do not apply with just one pattern. And this was this is why this work by Gang of 4 with those 23 patterns of object-oriented design is heavily criticized, because there are some connections between these patterns, but this work does not call for creating a whole architecture out of patterns, piece by piece. And I think, Nicola, that's what you meant by these rules. That we feel very, very good when we have really this in our hands. And let's have a look. Of course, these pattern sequences are part of pattern languages that contain all the patterns and possible connections between them. But this is something that we are never sure how all those patterns can be really combined with each other, not even in building architecture. But we will come to some particular examples in the software examples that will be occurring in the rest of the lecture. So enough with the building architecture. Sorry about this longer introduction to patterns like this, but it is really, I think it is beneficial to make parallels. If we are the very notion of architecture was borrowed from building architecture. And there were comparisons to how buildings are built, bridges are built, and so. But these comparisons are like all very light comparisons, very superfluous comparisons, like not in depth. And this notion of patterns that also is a part of building architecture, although it is not accepted by the mainstream in building architecture, is something that is very, very, very interesting to us and applies very much to software systems. So we could say that proven practices known as patterns always come out of the context in which the architecture is being set, resolving essential conflicts or contradicting forces. So these are not exact rules do this, do that, like strict rules with everything said within them, but they guide you towards generating some solution that is appropriate for a given context. So very much is up to you. So get back to software. What is an appropriate architecture for an interactive software system? This is a kind of software systems that most of you will be kind of dealing with all your life. There are some other software systems, some embedded software systems, which do not exhibit some of the essential properties of interactive software systems. And the most interesting thing with interactive software systems is, of course, that they are interactive, but interaction means that there are users, and there might be kind of many users with many different ideas of how the interaction should look like and what that system should do, and their ideas develop in time. So changing requirements and everything is connected to this. So if you think of interactive software systems, does any particular way of organizing this system comes to your mind? Do you think of any particular scheme? You can describe it or name it. I mentioned in the first lecture that there are different architectural styles, so how you organize your architecture. So would it be a kind of a pipe and filter architecture, or a blackboard architecture where different processes can put some data and collect data in a common repository? Probably not. That doesn't feel right. Probably something more like this. Model view controller. So are you familiar with this notion? With this, it is also being denoted as an architectural style. It is also known as a pattern. We will look at this model view controller thing as a pattern, but let's forget about that. Let's have a look how the thing is organized. So this is a purely technical view, and this is a kind of it's a structural scheme, but it enables us to explain how the thing works. So first of all, there is some idea of the thing that you develop. So, like, is it a kind of a banking system? Is it an educational support system? Is it an insurance system? Or is it a kind of a tourist travel system or whatever? So based on that, without exploring some requirements with the end users, or at least with talking to the client who actually who you build the system for, you may develop some model, not just to draw a model, but you can actually build a database. It might be a relational database, might be graph database, whatever kind of a database, but it is organized in some entities. And actually, when you have this model and you're sufficiently capable, like you are a programmer or even an end user that knows how to manage some things in databases a bit and so on, could use this directly. So write some data, read some data, and so on, and everything necessary will be kept there. But a common user is not capable of doing this and does not want to bother with this, not even us. So we would like to see this in a different way. So that's why we set some views or some view, and essentially we need more different perspectives on the same data based on whether we want to use this banking system as a client of the bank or as a clerk, and these are quite different perspectives. And different interface will be created for this. Essentially, you need then to connect these views to this model in order to be able to manipulate it. One line is to connect this directly, but these things will be also, these things need to be regulated on a kind of more subtle basis, because some events will come from the outside world. It might be just clicks from the mouse in the graphical user interface, or some signals from the equipment that is connected to the system, and so on. So these things might also affect how the model is set. So actually change the things in the model, and also might affect what the views reflect. So this is the thing and how it works. So you organize your software architecture around this, and you separate these things because you don't want to mix your model with the view or the views. You don't want to mix them because then they will become inseparable. So you would not be able to adjust properly your architecture, your system. You would not be able to apply different or introduce different views because the model is strictly adapted to some views and so on. So the controller that passes these events and regulates how views are connected to the model also is also to be good. It's good to be separated. It doesn't mean that you will have just 3 modules in your system. It's not that simple, but you need to distinguish these things and to regulate how they are connected to each other. And this is the idea behind this model view architecture. So this is a very, very common approach to interactive systems. You might have known this, and you also might know that behind this, to apply, to introduce this architecture, you would need to use some more specific patterns or ways of implementing things. And one way of seeing model view controller is that it is observer plus strategy plus composite, in the sense that these relationships between these roles of model, view, and controller are expressed or are supported by these patterns. You might know that observer enables you to have a subject and to notify the bunch of observers, whatever they are, regardless what kind of observers are they, who are connected to your subject whenever this subject changes. So this is something that you can really be helpful to implement the model-view relationship. And the same thing goes with similar thing goes with strategy and the composite pattern without we are not going to go into details. But I have these patterns actually here. I think this is observer. So let's check them a bit, not to spend too much time on them. But look at this. Again, we have this conflict of contradicting forces. Observing objects have to be notified of a change in the state of the observed object, but it has to be possible to add them without a need to modify the observed object. So your subject does not want to know too much about those objects that are connected. And if we get back to model view controller, you see that the model plays the subject role and the view plays the observer role. So your model in your model view controller pattern does not want to know very much about views. So the views will be just notified that something has changed, and that's all. You don't want to make this model be dependent on the views. Again, with strategy, this is this view controller relationship, which might be kind of a thing that the relationship might be more tight, and sometimes really controllers are implemented with thin views, more or less, but still there's distinction. If you remember, if you used sometimes in your life, like in object-oriented programming, in the object-oriented programming course, Java, you might have used JavaFX or some other framework, or Swing, or whatever. So you implement the listeners that you implement, and I think I don't have the exact implementation. Does this work like this? I don't know. I can't make it larger somehow. I forgot to look for what the option is to enlarge. It worked sometimes some time ago like this. Oh, it works like this. Okay, great. So if you look at this strategy pattern and its scheme in UML, so I'm showing you some UML artifacts. Although they're typically not essential for expressing patterns, they are very helpful, and even Django 4 patterns come with some kind of pre-UML object-oriented diagrams. So you can see here that there are different strategies represented as classes. So these are classes, and these classes share the same interface. The interface that the classes share means the set of the operations that they implement. And in some languages, this can be represented really as a separate construct, like in Java. In some languages like C++, you need to use abstract classes. In some languages, you don't have not even abstract classes, but you can pretend that you have them and pretend that some classes are abstract, which means that you cannot make objects out of them. So you have this prescription of the interface, and the whole thing is applied in a certain context. And this context is your graphical user interface control. This is your button, this is your text field, this is your label or checkbox or whatever. And this strategy is attached to the button. So typically these things are called listeners, or what's the notion in JavaFX? It's a I can't remember at the moment. Do you recall it? In JavaFX, in Swing, these are called listeners. In JavaFX, nobody remembers that. But you know what I mean. So these things, these are the actions implemented. And I think in C++, these are called actions. These are the things that are to be performed when you activate a certain graphical user interface control. And what's the implementation? Well, it comes in form of an object of a particular class. Usually, if you create a class, it's just a one-time use class. So in Java, these are anonymous classes. And there are more modern elements in Java. As Java developed, you can use Lambda expressions for this. But these are implementation details. But you will come to these things because you know Java or some other language, and you know what you need to do. And you know what's the tension. Once you see that or understand that the tension that you are resolving is that there are and can be added different strategies of solving a given problem, which are different actions associated with your graphical user interface controls. But the context of their application has to be ready for this. So you know that this needs to be somehow generally supported by the attachment of such strategies to the graphical user interface elements. This needs to be somehow supported. So out of that and out of your knowledge of or recognition of the solution domain, which is essentially the programming language, or the frameworks that you use along with it, you will derive the solution once you know what you need to do. So the thing is here more to know what you need to do than exactly how to do it. I think we don't have to analyze composite. Maybe just to remind you of this peculiar connection of this composite element. Composite is about having elements that can consist of can have certain parts, but also you have some atomic elements, or not atomic elements, or actually atomic elements. They have to be atomic elements. They are not composed out of anything else. They are just exact objects. This is represented by this leaf class. Again, we want to see these objects the same way and approach them, whether they are atomic or composed. And when they are composed, we want to be able to recursively go through their structure. And this is related to how views in views in graphical interfaces are being composed. You can have a window, and the window within that window, and within that window you can have a panel, and the panel contains buttons. Buttons do not contain other buttons. Yeah, so we are at a leaf at that moment. However, there are also other possibilities with how to decompose or to see a model view controller. And one of them is to see it as a composition of publisher, subscriber, common processor, factory method, view handler, composite again, chain of responsibility, and bridge. We're not going to go through all these patterns, but these patterns are apart from Like publisher subscriber looks like observer very much. Factory method is one of the gang of 4 patterns again. Composite is the pattern that I mentioned, and the others are a bit different. So there can be different opinions on how to approach this model view controller architectural pattern. Sometimes we call it architectural pattern. Sometimes all these patterns are considered to be design patterns and like vertically decomposed to other patterns. Actually, this view handler pattern can be further decomposed into several patterns, out of which you might recognize some, like singleton in particular, as one of a very simple gang of 4 patterns. These patterns, this definition of model view controller comes from pattern-oriented software architecture. I'm not going to bother you with all these things, so you can check this out on your own. And especially this is pattern-oriented software architecture book 1, which was an attempt, and it developed further. So there are altogether 5 pattern-oriented software architecture books by Bushman and other colleagues. This is a thing that has a different quality than just individual application of attempting at individually at applying design patterns individually, as in the gang of 4 catalog of patterns. So we will have a look at a different thing here. Once we finish with this model view controller pattern, in order to see to get a feeling of these Bushman's patterns and how they are being composed. But the thing why I showed these 2 different possibilities of decomposing model view controller. Why am I mentioning this? Is that it is probably good to maintain kind of a general understanding of what model view controller is, and accept that there are different ways of implementing it, even different like sets of patterns in the form of different sets of patterns that form this model view controller. And the understanding of this pattern is not based on how it is being decomposed into these patterns. It is based on what this pattern really is. And again, behind each pattern, there is a conflict of contradicting forces. So even here, we might have forgotten a bit about the user in this model view controller setting that we actually started to analyze. And Jim Coplin, who I mentioned with his pioneer work on patterns in the C++ idioms book, introduced together with the initial founder, to say so, if we can say that patterns are being found. The initial founder of the model view controller pattern, Trygve Renskaug. What a strange name, yeah. Like Trygve Renskaug is kind of the father of the model view controller pattern, and they approached this issue again and agreed that the user was missing in the initial definition, because it is all about user's mental model. Those views are actually a nice way of approaching this difficult model, complicated model, technically interconnected, very much things there. We don't want to bother with them, but we need them in order to capture the domain knowledge. But we need these nice views, as we have these nice interfaces when we talk to each other. So we are pleased to talk to each other. We would not like very much to like open each other's brains and mess with neural cells themselves in order to communicate and to understand each other. Sometimes we do not really understand each other. Maybe it would be much easier to interconnect like this, but I don't think we'll be very happy with this. So this model is the reality that's behind the scenes, and the user has a kind of an idea of how to manipulate it, and this is implemented in different views. And this is, the controller thing coordinates these views and model. So when we revert back to expressing this as a conflict of contradictory forces, we might say that the system has to comply to the user's mental model, but this requires coordinating multiple views over complex data. This is what guides us. Without this, if we say that model view controller is just observer plus composite plus strategy plus or in whatever order, observer plus strategy plus composite as I had it, or this Bushman's decomposition, which is more complex, maybe more covers more things. If we just remember model view controller by this, then we will be incapable of deriving or implementing this in a satisfactory way, because we will forget what's the purpose of this architecture. So any pattern, no matter how high level, is always can be expressed, or always behind that pattern is a conflict of contradicting forces. Look for that at all times. This is not always expressed that clear in the literature. So this is a word of warning. So this is up to you to look for this. In the community, I'm kind of involved very much in this research around patterns, but in particular with organizational patterns of software development, so with people. And I'm reading many papers at all times, like about patterns, and getting in touch with many people and many opinions, and I think that this is the most important misunderstanding that there is about patterns. And once you forget about this, that this is the conflict of the forces, contradicting forces, makes you make things. This is the flame behind the creativity, behind the building effort of whatever kind. If you forget that this is it, then you can say that anything is a pattern. And there are so many discussions, and people are embarrassed to say when some authors are presenting some patterns, or when we read some papers. Many participants of these workshops are embarrassed to say, "Oh well, I don't think this is a pattern at all," or "Why should we? Can we perceive this as a pattern?" So the thing is that a pattern comes out of the initial conflict. It resolves this conflict, but creates many more further smaller conflicts. And these conflicts are being resolved by further patterns, and the thing grows like this, like a tree. This is why we perceive such an architecture as a live thing. And as people, we hate dead things. Like, we don't feel good around dead things. We want to be in a live environment, not in a sterile, like polished completely environment. We do not feel. Just observe this: that you you don't feel well when buildings are completely like shiny and polished, all in glass. Might be like interesting to look at it, at such a building, but to live in it in a kind of a glass box, it's not very interesting. And look at this. This is from POSA 4, so by Bushman and the colleagues who wrote this book. This is also a way to express the conflicting forces, or the conflict of contradicting forces. It's more verbose, and it's a bit different. However, there's this however. So this but or however or something like this is is the breaking point. So something holds, like user interfaces are prone to change requests. However, changes to a user interface must not affect an application's core functionality. We can see things a bit differently, but there's always this conflict of contradicting forces. There are other architectures as well. So not just model view controller is an interesting thing to us. If you take a look at this scheme. This is Java API. I don't know, some version of it, but is this model view controller or something else? I know this is just kind of a graphical scheme of this architecture, but really, you have at the bottom you have this Java virtual machine, and you build on these things all the way to have a complete feeling of the Java language. So each thing that is depicted here relies on the thing that is underneath, and gradually, using these layers, you build the whole architecture. So the thing is that these layers enable you to cope with the complexity, because you need to have some kind of a separate understanding of the layer, but this layer, in order to work, it relies on the services which are defined in the layers below. So this is a way to organize software architecture. And in particular for frameworks, because this Java API is a kind of a overall framework. And actually, the Java language is almost like inseparable, or practically inseparable. Some time ago, when we had languages like C, you had the language and the libraries. Yes, and you knew that what is the C language, and you know when you learn like the comments, the keywords and everything, and how they should be put together, the syntax, you know how to program in this language. Of course, you need to be comfortable with using the most popular libraries, or the particular libraries that are used on the projects that you participate in. But in Java, the development of the language, and now even in C++ as well, we can observe this. But in Java in particular, like the generics in Java are established like in the language because they needed this to implement efficiently some things in the underlying framework. So the things, and nobody knows for sure, like we have to think hard which is which is it like a feature coming like the essential feature of the language, or is this a part of Java API? But let's get back to this layer architecture. So layer architecture how to implement it, because it's good to express it like this, as I said. Maybe I even have this conflict of contradicting forces somewhere noted for the layer architecture, but it is important to understand what's behind it. But then it's important how to achieve this. So each layer provides some interface. Each layer provides an implementation. So one way of dealing with this with these interfaces is to apply the explicit interface pattern. How do you know this? Well, you are dealing with interfaces, and you have these books on patterns, and you look for these things, or you learn this from experience, simply working on these things. The implementation, what we have inside of these layers, consists of some things, some objects, and these are domain objects. What are these patterns actually? These are further patterns that apply to these kind of higher level patterns to implement them. We will see in a moment, but the interconnection between layers, the notifications that are being sent, again might resemble observer. This is the pattern that we analyzed a few minutes ago. And this is how we get to patterns to work. So we compose them, we build, we set one pattern based on the initial conflict, and then look for the patterns that help us resolve the details, resolve the further conflicts that this initial solution created. This initial solution that somebody tells you, okay, or you decide that you will use model view controller, you decide that you will use layers or whatever pattern for the initial setting. This does not mean that you already have your code somehow organized. This is a decision that you made, and it kind of seemingly does not have like this house. When I draw a scheme like this for a house for a small family, I did not do anything with. I did not start building a house. Actually, I did not collect any material to build it on, or I just made this conscious decision, and it's good to know where all this started. And then eventually we'll come to the things that will make you create some code. Maybe even this initial decision will make you like set initial things, set the initial like packages or something like this. Then it's very important to remember that those top-level patterns, which represent actually pattern compositions, or these peer-to-peer compositions, represent as well can be as well represented or described by conflicts of contradicting forces. So let's Yeah, I don't. I have it. I have this more detailed view in the next lecture. I thought it might be good to show you one more thing which I don't have explicitly, but we will talk about the details in the next lecture. But let me just show you one small thing. This is it. So, what we are going to talk about in the next lecture is how this layers architecture is really applied on this example, and we will see these patterns that I mentioned. I did not include them in the slides of this lecture as described as conflicts of contradicting forces. So this was just a kind of an initial setting for what we are going to go into detail in the next lecture. So we will remain with patterns. So don't worry. So this is not that like I'm leaving you with this. Okay, patterns are there. There are many patterns, and there are conflicts of contradicting forces, and just find your way through them. So we will go through some specific patterns and see how they are related and how they are being composed like this. So don't worry about this kind of a bit higher view of abstraction in this lecture. So let's just then recap by these conclusions that are shown here, and we have some time for your questions or remarks. So think about the patterns as you knew them previously. All of you came in touch with some observers, visitors. Maybe even the bridge pattern is not one of the patterns in the Gang of Four catalog, or some Java enterprise patterns and some other special patterns. And have a look at your favorite patterns or some patterns that you read about before, and just to observe whether there is this conflict of contradicting forces expressed somewhere, or whether you can derive it from the description. I also couldn't find this kind of description of the observer pattern when I was reading, I don't know, numerous times. I read the description of the observer pattern in the Gang of Four catalog. So I had to derive it myself. Sometimes these things are expressed, most often they are expressed in a kind of a little bit obscure way, not really explicitly, and very often you need to build this understanding based on the examples, on trying to implement the pattern, on thinking based on thinking about the pattern, and such things. These things are not easy, of course. Okay, so any other questions not specifically related to this topic? We don't have to get back to the project and how to choose the topic, how to write a project objective. It doesn't seem so. Okay, thank you for your attention. See you next time. So we'll continue more deeply with Bushman's patterns, pattern-related software architecture. Kto má výskum inteligentných softwarových systémov, pripomínam, že budeme mať dnes seminár. Tu. Áno.